Hello and welcome to the 23rd episode of the Game Dev Tutorials. Today we are going to be going over implementing AStar, and there's not a lot of steps, but this one's a doozy. So, yeah. Steps today are going to be to add and fix the code in grid location. There were some things I stripped out before that I needed to add back in, so that's there. Then we're going to add all the code to the grid that we need for our AStar. I put my AStar code in the grid. You can do whatever you want. You can put it in your unit or wherever you want. To me, it feels best to put it in the grid because you're basically doing an operation on the grid. But I have seen people put it in their unit class for whatever reason, so I'm just going to throw that out there. This is going to take a while. I'm going to copy paste this and explain it. It's too long and precise for me to type it all out in this video. It would be like a 3 or 4 hour video. Alright, then we're going to add some code to unit and the two functions. One's for moving the unit, because we're no longer just using radial movement. And then we have to add a function for find path so that we can we actually don't need it for this, but it's good practice. You're going to want it there. I whittled these down, not just these two functions, but all of this down from a ridiculous amount of code to the simplest thing possible. It actually probably would have been faster for me to rewrite it, to be honest. But I also didn't want to forget things, since some of this code I hadn't done in a long time. My AStar functions are much more complicated usually than these ones are, and yours will too as you add to them. But if I try to explain those, then I don't feel it's very understandable for people. I've actually had people that I had interns or whatever at times, and they had their brains blown up by these. So I try to make them as simple as possible. Hopefully you guys understand that I'm not presenting you with the greatest AStar code in the world, but I hope that it's a very understandable AStar and that can get you guys kicked off in the right path. Pathfinding anyway. But a little bit of a pun there. But it's hard to think in terms of AStar for a lot of people. I am sure that there are people watching this that are going to be like, yeah, that's simple. Okay, that's fine. Cool. But I'm trying to simplify these. So, hey, if you think that they're too simple, ask in the comments for a more complicated one, and I will, show it. I'll also probably discuss it a little bit. What improvements you can make to your AStar that will help. And then the last thing we're going to do is we're going to change the spiderling to use the AStar code. So right now, the only unit that we have that targets a static location is the spiderling, because it goes straight for a tower. And so that's going to be the easiest of everything to apply our AStar to. So that's what we're going to start with. We are not going to do all the mobs today. We are just going to get the spiderling working. That's it. All the other mobs come after you, so that is something that we will need to deal with in the future. With the spiderling, you can set it and forget it, right? You can just let it go. Technically, you would need to update it if you drop a tower, but we're not even going to worry about that right now. All we are going to worry about is a static. When the spiderling spawns, it finds a path that is clear, i.e. walks around your towers, to get to your little home tower castle thing. So yeah. So quickly, a bit about AStar. I guess I should have brought this up before, but let's create a quick little grid and let's talk about it real fast. How AStar works. So, you know what? It's faster if I just do this. There we go. I'm not the greatest Photoshop person because, again, I'm not an artist. But I understand enough in order to get a little bit done. Alright. So this is our wonderful grid. Totally simplified. No big deal. Could have prepped this before I did the video. I will probably cut this part out. Okay, so if you are here, maybe a circle there, and then an X, and you want to get to, actually, let's do something slightly more interesting. You want to get to there, but this one's filled, and this one's filled, and this one's filled. All right, so in our AStar nodes here, we would test from here. We would find this node, and this node. This node is the closest to here, so it would test here. And it has a low F score. So the F score is how far it's traveled. So in here it's root 2, 1, 1, right? So it tests the, well, however you want to test it. But in the case I'm going to show you, it is going to test the item that is a combination of your F score and closest to the location we're trying to get to. So we'd go here and here, right? Find these. So we're going to have root 2 plus 1, root 2 plus 1, 2 root 2 here. Okay? 2 root 2 is closest and has a decent F score. It should be the one we test next. It finds no new nodes. Actually, it would find this node. From there, we've moved backwards. And because that happens, usually this node is now going to be tested as more important, because this F score is low enough, because this one's now 3 root 2, and this one is root 2 plus 1. So that combination of math is going to cause this one to be tested. So it'll test this one, find that it's shorter to get to here, because instead of being 3 root 2, now it's going to be root 2 plus 2, which is substantially shorter than 3 root 2. So it will then overwrite the path to this one as this is its parent. So it saves its parent. So now our path is this. That'll test here and here. Obviously, this one will be the choice. That'll test here and here. That one should be the choice, I believe. Then I'll test there, there, and there. That one will be the choice, and then that'll test these 3, and that one will be the choice. So that should be, for instance, for this, the AStar goal, I believe. It actually might have come back down this way, because that's too high, and then it would have come to the 1. It probably would have come down this direction. But anyway, let's pretend that this is covered. And now what I said is true. I'm not a computer, so I'm just doing my best to calculate what's going on step by step. But so it would have first come down here, then gone up here, then realized, nope, that's too far. This node is now a better one to test. Come through here, found this node. When you find a node that you've already been to, if the path, the F score is smaller, then you set the parent to where you're coming from. Hopefully that made sense. If it didn't, ask. I will happily answer questions. But so essentially the process is first find all adjacent nodes, then you sort your list of nodes that you've seen. So you add these 3. All these dots are nodes that you've seen. That's what those are. Those are visible nodes. Okay? As you pass through the nodes, you move your nodes from the visible list to the used list. Okay? If you see a node that is in the used list, then if the F score is lower, you change the parent. Okay, that'll keep giving you the most efficient path. You end your AStar when either there is no viewable nodes left, so if it was completely blocked off, eventually you'd end up with no viewable nodes left, or you reach the end. And then you'll have this node, and you'll have the parent, so you just look at all the parents, and then you'll find the path. Okay? Alright. Let's get into code a bit. And then you might ask, well, wouldn't it be better if you ran a path that looked like that? And the answer is yes. But smoothing out this path is more difficult to look like. Sorry. This is what it would. That's what you really, really want. But for right now, we're going to have this jagged one. And we'll work on smoothing it out maybe later. Okay. Code-wise. Now, here comes a lot of work for me. We have our grid location. Let's add that code in first. And that is in our engine. Grid location, square grid. We're going to need that. We're going to need unit. Might as well get them all open right now so I don't have to go back. And mob and spiderlink. Okay, we're going to need all of this. I didn't get unit. Unit. Okay. Spiderling, mob, square grid. Alright, get all this in before I forget. Now, grid location. We need to add been used and is viewable, and the reason we do that is because the bools are just more efficient to test for. So it's caching. Caching is more efficient, so we're going to do that. Okay. A couple more things we need to add to this stuffs. We need to add set node, which is a function. I am going to give you this class. That's why I'm copy pasting right now. So just bear with me, okay? And then we actually need to add our bools, initialize our bools. Okay. So I just set them to false, right? Just they're nothing. They're not doing anything, but we need to have them. Set node just allows you to set the parent as well as the f-score and the current distance. So very simple stuff, but it's important for AStar. And then the last thing we got to do is fix the spelling issue, because I'm already getting harped on here and there in the comments about my spelling. I apologize. Spelling is not something I do very well. It is something that has eluded me my whole life. Math and science and all those wonderful things work great in my brain. Spelling not so much, especially English with all the rules that don't work. But anyway, I apologize here and in advance for all other videos. When I misspell something, it's because I don't spell well. So, sorry. Wonderful thing about programming is it just doesn't care. As long as it's always spelled the same, it doesn't matter if it's spelled wrong. So, yay, woo. But anyway, okay. And so that takes care of the little bit of maintenance here that we had. Our next bit here is in square grid, and this is the doozy, right? This is the mamma jamma, right? Now, I told you I do things in alphabetical order. I never do this part in alphabetical order, and the reason I don't is because it all goes together. So, okay, let's see. What do we do wrong? What do we do wrong? We have a different constructor here. Let's look. So we are using. I didn't even realize I was using a different constructor. We are using this constructor. Let me grab it for us. Didn't even realize I was using a different constructor. Okay, that's our constructor we're using. The difference is it sets it whether it's filled. Oh no, just all it is the f-score. Is that it? Oh, and the position. So it puts a position in and the f-score. That's it. No big deal. Okay. I use that, and you'll see this in just a second to set up the grid. So region AStar. I put it right above draw because I don't know. Because I've always done it that way. And I understand that they are out of alphabetical order, but I put it in one region, so they're all together. There are 4 functions in here. There is getPath, which basically runs the whole thing. It's what you call from outside. You have test AStar node. We'll get into all of it, don't worry, I promise. We have set the AStar node, which is called by test AStar node. And then we have set AStar node insert, so that just inserts it in. Again, you should. I actually rewrote this so that you could just have a regular loop. But this should be inserting, because it's a sorted list. So you should use like merge insert or what's the other one? Quick insert from merge sort or quick sort, which have in login time instead of in squared time. But I don't want to get into really, really complicated stuff, and I haven't gone over sorting with you guys, so I went with the simplest sorting. So before any of you guys jump on my butt about not using merge sort or quick sort, I know that it's supposed to be using merge sort or quick sort here. If you don't know what merge sort or quick sort are, look them up. They're very important. You want to get your programs running smoothly when you're sorting, then you need to use them, because in squared is, I mean, it's not horrible. There's much worse, but in login is substantially better. It's when you get to like 100 or 200 or 1,000 items, it really starts to make a big difference. The in login one is just going to be, I don't know, it's exponentially better. So it's hard to explain exactly until you understand what I'm talking about with these big O notations. Explaining them, I'm not a teacher, so one goes up, like 4 is 16, and in login I think is like a 4 is like 8, but when you get to 100, it's 10,000 for x squared, and it's like 1,000 for in login, I think. I mean, don't quote me on that, but so you're already at 10x lower, and then if you get to 1,000, it gets ridiculous. So you're at 1,000,000, and then you're at like 38,000, 33,000, something like that. All those are off the top of my head, so if I have those wrong, I'm sorry, but those are close to the correct answers. So rather than running a million, you're running 38,000 calculations. That's a lot better. Okay. Let's go and let's talk about what the AStar actually is doing here. Okay. Now notice. Let's see. We go from this is 233 lines of code, and that's why I'm not typing it. Okay. Get path. It takes in the start point, the end point, and if diagonals are allowed. So let's look. The example I was talking about here did allow diagonals, right? There's a diagonal. Otherwise, it would have just seen the perpendicular ones. Okay? So does it allow diagonals or does it not? Sometimes you want them, sometimes you don't. It all just depends. Okay? So next thing we do is we create the viewable and the used lists of grid locations, and the master grid, which is a list of grid locations. So it's basically a copy of our grid. We are copying our grid so that we can make changes to it without actually changing our grid. Okay, this is copying the grid. Not a whole lot to go over here. It's just a double for loop that sets the impassable numbers, the cost of each slot, and sticks them into copies of grid locations. This is the constructor that we just added right here. This constructor right here. Why are we setting F score to all 9s? Because we want it to be a horrible F score so it doesn't get picked early until it gets set. If you set this to 0 and then you have a bug in your system, then it's going to start calculating them out of order. This way, if there's a bug, it's just going to push it to last. Believe me, that's better. Cost in this case is always 1. We don't actually set costs yet in this game. We could. For instance, if we have like little swamp tiles or whatever, we can make those cost like 5 or 6 or something. And that'll change it out. And the position is the grid location. Okay, that's important for later, so keep that in mind. This is not the position in screen space, this is position in grid space, right? So I mentioned grid space earlier. Grid space is, I don't know, it's like 50 by 50 or something like that, whatever we're using. I'm not sure because I haven't looked at it But let's just pretend for a second it's 50 by 50. Whereas our screen space is 1600 by 900. So very, very different. So keep that in mind. To viewable, we add the start node, right? Because we need to know where the start is. So the start node is automatically viewable. Okay. And then this is actually where a lot of pretty much everything happens. So we have this while loop. And it basically goes as long as viewable is greater than 0 and viewable is not equal to the end position. Okay? For that, then we're just running test AStar node. We'll get to that in a minute. After test AStar node is done, we will have a path to deal with. So the viewable node that is in the front of viewable is our endpoint. And if viewable count is equal to 0, then we didn't find a path. So that's why we're testing here to see, hey, is viewable count greater than 0? If the answer is yes, then we have a path. Okay? Current viewable is 0. This, I don't think I even use this right now. Okay, I do, but it's only for error checking. A lot of this is completely unneeded. But anyway, we'll get to that in a minute. So, as long as that's there, we go through viewable, and each time we set viewable, the current node, equal to viewable parent. Where is it at? Which one are we using here? It gets set to the parent. Here we go. So this is the one that's actually going to be used. That's the only code path right now that's going to be used. I should have simplified this further. I should have. Oh well. This is the only, and I'm going to say it again, code path being used here. It won't get into any of the rest of this. That's all extra stuff. I hesitate to copy it out just in case there's some reason I'm wrong there. This should be all that's used. Anyway, going through it step by step. So it takes in the parent, gets a new current node, wraps back around, goes back into our while loop, adds another node, comes through, gets the parent, comes through all the way until the end, right? It just loops until the parent node is the start. See? And then it breaks. So it gets out of here. So that gets us to here. That will give us a backwards path, right? Because we started at the end. We don't want that. So we use path.reverse. I understand that is a C# function. Usually I write everything out for you guys. I don't use the built-in stuff all the time. But that reverses it for you. So if you're not using C# and you're trying to implement this for something else and your lists in that language don't have a reverse, you just run a for loop backwards and reorganize it. It's not crazy. Okay, and then we return the path. Okay? So we return the path out to whoever called this, and we've got it. So now back to creating our AStar, right? This is the magic, right? So what is this supposed to do? This is supposed to find viewable nodes and to set them. Okay, so we come down here. This one takes in our grid, takes in the viewable list, the used list, the endpoint we're looking for, and if diagonals are allowed. Each one of these blocks, like that's above, that's below, that's left, that's right, okay, is locations that it's testing for. Remember, our grid, it's only testing for adjacent locations. Now you get to decide whether you're counting diagonals as adjacent or not. Right now we are. So we will pass in diagonal allowed true, or allow diagonals true. So we'll have all of these. So this is the above node. This is the below node. I'm going to go over these in a minute. Left, right, up right, down left, up left, right? So we have each one. Can you loop these? Yes, you can loop these. Okay? So if you want to loop these, probably a good thing. It'll cut your code down. But I wanted to show it working. Okay, so what are these things? Well, first off, we're looking at the viewable position, viewable 0, so the top of the viewable stack. And we are checking for above. Well, what is above? Well, above is the y pose -1 and x no change. But it is testing. It's going to say, okay, we got to make sure that y is greater than 0. Why? Because there's no above it. If it's greater than 0, that will crash your game. So we got to test for that. And then we got to make sure we actually don't have to test for this, technically. We could test for that only on below if we wanted to. I test for both just because I don't want to worry about it. Alright, and then we check to see that it's not impassable in that location. As long as the path, the location is tested and exists and is not impassable, then we set the current node to that, right? And we set up to the same impassableness as this, which is null, or is false. Okay, and that's important for a minute, so just realize in a minute, so remember that. Look, we set up, we set down, we set left, we set right. Okay, and then we set the AStar node. So that's the next function, but we'll get to that in a minute. So consider that in a second. Now, each one of these is the exact same, except for we just change out these, the end portions here. So +1, and this one doesn't do anything. This one's -1 because it's above. This is below. So then we come down here, and we're going to have to the left and nothing, to the right and nothing, right? They're all identical except for the bools that we change and the numbers there. That's why you know you can loop it if you want to loop it. Now, for allow diagonals, the reason we have these puppies here is because at the end of these, it's going to check for those as well. So one of the two, I have it set to one of the two needs to be open. So let's take a look what that means. So let's say you have, so this one's blocked and this one's not. We still allow the diagonal to come through. You could choose that you need both of them open in order to allow it to go diagonal, in which case this path would become this, right? It's a less efficient path. Whoops. And I don't like it that way. So I like to have it single. But if you wanted to change this, instead of or, say and then you're done. So, yeah. That's the only change there. And so that is the difference between these diagonals. It's also in an if statement. And the direct directions. Okay? And then here at the end, we set the current viewable to been used, meaning we visited it, and we add that node to used, and we remove it from viewable. Okay? Now, setting the node. Setting the node is here. So right now we're just setting f-score to distance. My f-scores are almost always substantially more complicated. I put it to just this because this is where I started. And I remember this is where I started. So, usually my F-score is, I don't know, a bunch of things being combined. Very complicated functions. In this case, we're just going to use the distance for our F-score. Okay? We have dist added. Okay, distance multiplier and then the cost. So, distance multiplier is like whatever the dist is. The actual distance. So, like, here we have math.square-root 2. And the distance is just current distance to the item. So they're a little bit different. And then so here we just have ones. And then, again, just in case you don't know how I got that math, if you have a right triangle... Whoops. Boy, it'd be good if I was better at this Photoshop thing. If you have a right triangle, right? And these are 45s. 45 degree angle, and this is 90. So you have 45, 45, 90. This is 1, 1, root 2 times whatever it is you need to do. If you have a 30, 60, 90, so this is 60, 30, 90, then this is root 3, I believe. Or 2 root 3. It's 2 root 3. And then this, I forget these, to be honest. But I remember the hypotenuse. Off the top of my head. So, this is 1. This is, I want to say it's 1/2. But I don't remember. Don't take this one. Let's just forget that one for right now, because I don't remember off the top of my head. But I think it's 1/2. But anyway, this is the one that's important. These are important triangles from geometry. And this is root 2, and the diagonal is the same thing. It's a 45 degree in our grid, because our grid is a balanced grid. It's a 45 degree angle. So that's our root 2. Okay? That's why it's root 2. And that's my cat meowing. Hi. Okay. So back down here. So our simple f-score is just based on the distance it took to get here. And then we have the distance multiplier, and then we have the cost. So the distance multiplier times the cost. So let's say you're moving diagonal, and the cost is 3 on that node. Well, then you need to have 3 root 2, right? So that's why this is what it is. Okay. We get here, we say, okay, if the next node is viewable, meaning we haven't found it yet, and it hasn't been used, then we set the AStar node, we set the viewable to true, and we insert it. We'll get to the insert in a second, although we kind of already went over it. If it is viewable, then we check the f-score to see if the f-score is less than the f-score, and if it is, we reset that node. So we get the new parent, we get the new f-score, the new distance, we get all the new things. And then our sort. Our sort just inserts it if it finds it in the right spot, and if it doesn't, it adds it to the end. Right? So, pretty simple stuff on that one. In a nutshell, that's AStar. And I realize that's a lot to take in. That's a ton to take in. You may need to listen to this a few times. You may need to ask questions in the comments. I'm happy to answer them. I am giving you this code. You do not need to be typing this all out. I'm giving it all to you. It'll be in the provided materials, as well as the grid location. The stuff I'm about to do in unit and mob, I am going to probably type out. So, well, we'll see. We're already at, I don't know, 30 plus minutes. But anyway, AStar is tricky stuff, guys. It's, first of all, you can't even test it without 200 lines of code. So that sucks. And then little errors make big, weird things happen. I wanted to go over one other thing. So when we are getting the node, the position of the nodes out, and I want to talk about it because I make a mistake every time I rewrite this for this. And it's, say, so we were in grid space, right? We have to convert it out of grid space. To convert it out of grid space, we have to use the get position from location, use the location of the position, and then add half the dimensions to get to the middle. I swear every time I rewrite this thing, I forget to take it from grid space to screen space or game space, whatever you want to call it. So if you're writing your own AStar, make sure you do that, because otherwise everything just goes up to the top left of your screen. It's kind of weird. But yeah, all right. Let's talk about what unit needs to add. And now I got to debate on whether I'm typing this or not. I should type it. I should type it because I feel lazy if I don't. So unit's going to have a couple things added to it. Protected, vector 2, move 2. Why is it protected? Because you do not edit this. This is specifically for and only for pathing. Don't edit this outside. If you choose to, that's on you, but I'm telling you, don't do it. Protected list vector 2 path nodes equals new list vector 2. Okay. Move 2 equals vector 2.0, right? Because we're just setting it to nothing. All right, we got a couple functions. So we have our find path function. And our find path function takes in a list of vector 2s. So public virtual list vector 2 find path, and then I said takes in a list of vector 2s. It outputs a list of vector 2s. Kind of a big difference there. And then it is going to need to see the square grid. Grid is going to need to see vector 2s. It needs to know about the end slot. So that's where we're going, right? First things first. When we're finding a new path, we clear our old one. That's not going to come into play in this particular example, but you want some crazy bugs, don't clear your path when you find a new one. Okay. Let's see. Then we need to find our path, right? So we'll say vector 2 temp start slot equals grid dot get slot from pixel. Remember, I told you I love this function. I use it all the time. Temp start slot. That doesn't sound right. Nope, that's not right. The position of our item, and then that's already in screen space, so we don't need to use vector 2 0. Remember, if we're getting mouse space, which is like the front of your monitor, if you want to think about it, because I think of the monitor as depth, whatever, because with the 2D objects you can assign depth to things. Your mouse is your very top layer, right? Nothing goes on your mouse layer except for your cursor. So it's the very top of your screen, and it is always 0, 2 screen width screen height. Your actual game's space is not, right? Because you can scroll it around, and we're already in that space, so we don't need to add the offset. Okay. Let's see. After we find our path, oh no, we need to find our path because that's not our path. That's our start spot. So we have the list vector 2 temp path equals grid dot get path. There it is. And we have temp start slot end, and then true, because we are going to allow diagonals. It's end slot, not end. Fair enough. Okay, and then here we're going to do a quick testing because eventually you will need to know this stuff. So temp path equal null. Right now it should not get in here unless you block the paths off. We are not going to test for that right now. We will deal with that another time. This video is already running super long. It probably will end up my very longest video so far. Alright. Now, that doesn't do anything, but you should not get here. So if you want to put a little breakpoint there, and if it hits here, then you're like, where did it get there? I don't know, because it shouldn't get there. Something is wrong if it gets there right now. Either you blocked an entire path off, possible, but you'd have to work to do it, and then it's your own fault. because I'm telling you not to do it. So if you do it, it'll break, or it should break. And then we're going to return our path. Okay, and then the other function that we need is actually moving the unit. So public virtual void move unit. Okay, so move unit occurs and actually does something when we are having ourselves a path, and that path is, so it's not an empty path, and that the move to is equal to the position. You'll see, just one second. So pose.x not equal to move to dot x, or pose.y not equal well, my fingers got off there, move to dot y. Okay, so here we are going to do our old radial movement, right? So this is, we're moving in one small little segment. Let's go back and let's look. So when we're moving from here to here, we can use radial movement. When we're moving here to here, we can use radial movement. So each segment is done with radial movement, and that's because when you round these off, you really do want to use radial movement to get these nice smooth things, and then you probably would round kind of like this, and down. Actually, probably round off like this. But anyway, we'll work on that in a minute. We'll work on that another time, actually. So position equals globals dot radial radial movement, and we are using move to, pose, and speed to get what we want there. So now, what happens if we've reached the move to location? Well, so let's say we're here and we're moving to here, and we get there. Well, now we need this to be our target, right? So we've got to do that. So else if path nodes dot count is greater than 0, because remember, if you don't have any path nodes, then you're kind of done. So let's only do this at this point. So move to equals path nodes 0, path nodes dot remove at 0, 0. And then we are going to do the same radial movement. Now, why would you do a radial movement here, you might ask? Well, if you don't, you get a 1-frame skip. It stops for 1 frame. If you want that, put it in. I don't like it. I like to move smoothly. I just, that's the way I am. And then last thing we're going to do here is we're going to say rot plus equals globals dot radial, no, rotate towards, globals dot rotate towards, move to, pose, no, pose move to, sorry. I don't know why these are backwards on this one. This one's backwards, but it's always been that way for me, and I can never change it because I have to change it in hundreds of places in my code. Okay, so we move it, we change the nodes when we need to, and we rotate it. That's what move unit is. This can get much more complicated later. This one, I guarantee you, will be more complicated because you will want to, like, you see how these nodes are here all in a row? Well, you would just remove this node and move from here to here. Same thing here. So those go to those 3, you would remove this node. So removing excess nodes, you want to do that just for data storage reasons. You want to, so for instance, here we would probably move this up to here. Here. This node, instead of being in the middle, we move it to here. And we move this node to the bottom corner, and then we would want a path like that. So that's one way to smooth that out. Then you have this, you'd have to create an arc. That's a little bit more tricky. And then this one here, what you could do is you could test for this node, and then you could path pretty much straight there. But anyway, you'll smooth these nodes out, I guess is all I'm trying to tell you. Right now this is a very rough AStar, but you will want to smooth these out, and you would do those usually here, because you may not want to smooth out every path exactly the same way, so you do it in your find path area. At least that's my experience of it being the best place to do it. If you feel like it needs to go on the grid, do it there, but that's a call you have to make. Alright, so hopefully these are pretty understandable. They're short in their current forms, and then also this can get much more complicated as well, but you'll find those instances, or we'll go across them at our own pace. Now, spiderling. First thing first. Square grid. We need you. That's gonna bust some errors if I build it. Yep. And then that will be findable in mob. Mob needs it here. And then that'll break elsewhere. This will be grid. And then this is fixing my spelling. Got that. Now we should break for the other. Oh no, because the only AI we changed was the one in Spiderling. That's good. Alright, so we needed access to the grid. Now, this is going to be a little bit of reordering here. So we still need to find where we're going, which is great. We still need to know if temp is not equal to null. That's awesome. But inside here, we're going to have an if around this stuff, else around this stuff. Awesome. Okay. Now, we only want to find our path. Now, this is finding a path. Okay? So, keep that in mind. This is going to be our finding path. It used to just be, hey, move towards the thing. No good for our path anymore, right? So, we only want to find a path when path nodes is equal null, or path nodes dot count equals 0, and pose dot x equals move 2.x, and pose dot y equals move 2.y. If you don't put in this last part, it will move until the second to last node, and it will continue finding a path instead of moving to the very last node. So just understand that. And that's because the path nodes are stripped out before they're completed, and that's for a good reason. So just keep that in mind. So now we have this. We don't need to do the rot anymore because that's done in our movement thing, right? And then what we need to do is we need to say path nodes equals find path, and our find path looks at temp.pose. So remember, we still needed to find our building. That's our temp. And then it's gonna go to. Oh no, that's not right. None of this is right. Grid. So we need to have our grid, and then grid dot get slot from pixel. 0.0, and this is temp.pose. Okay, so we pass in our grid and the location of the end, which is the location of this building. And actually, you'll find, at least if it's the same as my test program, the building's kind of like on a border. It's weird because it's not set at the grid yet. We'll have to fix that later. Alright, so we're no longer going to need this. We need to set our move to, because our initial node is not accounted for. So we do that, and then path nodes dot remove at. You actually don't have to remove this. It'll just take that first frame to do it, but I like to set it up so where it's nice and working well. Okay. Now, this here, we have a better number than 15 now. We no longer need to use 15. We can use grid.slotdems.y or slotdems.x. And then maybe give it a padding. So I'm going to give it a padding of 0.2. So the reason I give it the padding is because I want to make sure that it hits it. That's all. It should be just fine with a 1. It actually should be fine with a 0.5. But we're just going to go with that for now and leave that there. Now, here, we need to move our unit. Okay, so if it has a path, we're moving the unit, and then we're testing for hitting things. Just there. If it doesn't have a path, we're finding the path. Right? So that's what we're doing with our wonderful, wonderful AI. Realistically, no, it's all good. Okay, so our spiderling now knows where to go. You know what? For testing purposes, we're going to set them to shoot every 12 seconds because the towers were shooting way too much because I was building way too many of them when I was testing this. So let's keep that in mind. All right, here we go. Only the spiderlings should be affected. So let's start putting in. I want to fill that one in. And we'll create a gap. And so now we're going to look to see where our spiderlings go. This one should come down here, go diagonal, and come over. Ooh, we got some crazy stuff happening. Alright, I will have to see. They're going up to the start, which is not good. That means that something didn't get initialized right. Let's see. Alright, let's check unit. Looking at here, because the rotation was crazy. It's not plus equals, it's just equals. Okay, so that takes care of the crazy rotations. I believe it's moving to top left because that's where move to tells it to be. So that was a mistake. New vector2 pose.x pose.y. That one's my fault. I wish I could say I was just testing you guys on that one, but no, that was just my mistake. So set the position of the move to where you are to begin with so that it calculates it. That's good. Our last issue is that it was not moving around our towers. So let's take a look through Square Grid, even though I copy pasted it, so I don't think it's the problem. Let's see. Is our grid being set up correctly? That looks correct. You know what? I didn't check this new structure I added, and it doesn't have impassable being set. Okay. All right, let's take a look at it. Play. Oh, let's set up our stuffs. See it go around. Yeah, look at there, it went around it. That egg will be interesting. Oh, that killed like an idiot. Let's see, that one should go over this way. Yep, and it did. It goes around it. Good. Let's add a little bit even crazier. Oh, and it goes around it. So, alright guys. That is our tutorial for now. That is the end of this one. We have working AStar in our game. Very primitive, very jaggedy, very whatever, but it is AStar working. It will path around things. They are flickering a little bit. I'm wondering if they're stopping for some reason, but we can deal with that later. Alright, if you liked it, please hit that like button. If you have not yet subscribed, please do so. I'm trying to put out 1 or 2 of these a week. 2 is the goal. On more difficult ones like this one, it's only going to be 1 a week. And consider Patreon. That'll help the stream out a lot. And if you want to support me without using Patreon, I do have games on Steam. You can grab one. You know, that way you can do like kind of a one-time help me out. And then lastly, if you do pick up the games, it's always nice to get a review or 2. Yeah, you know what, guys? Have a great day. Hopefully you guys learned something about AStar. Sorry about the couple of bugs that I had on there. But, yeah. Always like to get AStar in and working, and then we can adapt it and make it do what we need it to do as we go. Alright, all. See you guys next week.